Hello everyone, we're going to be looking at a worksheet. It's a POGO worksheet called Naming Ionic Compounds, and basically this is going to be a chance for us to just kind of go through and do a little walkthrough of the stuff that we've been learning last week and then pulling that back together again in just another form. We're just trying to build a nice foundation here so that when you actually can write ions into ionic compounds and things like that, that you know what you're doing. So anyway, what I have here is a model, an ion charges for selected elements. And so this isn't the entire periodic chart, it's just a few things, okay? So we've got hydrogen over here and beryllium, which is a +2. Remember, everything in this column is a +2. Everything over here is a +1. We have some transition metals here in the middle that we're kind of looking at, and you guys have already seen this. We have a couple different irons, don't we? We have iron +2 and we have an iron +3. Same thing with nickel, there's a +2 and a +3. For copper, there's a +1 and there's a +2. Zinc is always a +2, always. It's always going to be a +2 for zinc, every single time. That's one of those that you just, I don't know, you just, after time and experience, you just learn how to memorize that that's always going to be a +2. And the same thing with silver. Silver is always going to be a +1 every single time. Most things, though, that are transition metals, they're going to have multiple oxidation states. So like this one's a +2. Whoa, that has +2. Oh, Hg2 +2, and then Hg has a +2. So anyway, of course, aluminum is in group 13, so it's going to be a +3. Then we've got, the ±4, but look down here. Tin can actually be a +2 or a +4. And lead, same thing. It can be a +2 or a +4. So that's kind of different. And then, of course, group 15 is going to be getting into the -3s, and then the -2, and of course the -1. So some of the stuff you already talked about quite a bit, and so hopefully that's nothing, super surprising or new. The next thing I want to show you, though, is down here, everything over on this side that's a plus ion is called a cation, okay? So cations equal plus charges, and then anions equal minus charges, okay? And there's the anions over on this side. Just to kind of let you see that that's where those two terms also have come in. We've talked about cations. Remember, I told you that I love cats, and cats to me are very positive, and they make me smile, so I would think about them as being positive. Anions, it kind of looks like an onion. Okay, it kind of looks like that, and those make me sad or make me cry, and so I think about them as being negative, and that's just how I always remember those. You can remember them however you want, but that's how I always remember positive and negative, cation, anion. Okay, so based on the information in Model 1, identify 3 elements that form only one cation. Well, let's see, there's tons of them over here. So I could put in here lithium with a plus charge. I could put in here calcium if I wanted to with a +2 charge. Or I could say barium with a +2 charge. But you could do any of these over here, right? So any of these guys or these guys, or even this one, you could do aluminum too if you wanted to, right? Aluminum is a +3 charge. So any of those would be examples that you could do. You just need to put down 3 of the cations that only form one type of cation. Now the next one, it says identify 3 elements that form only one anion. Well, that would be any of these guys, right? They all only form one anion. So I could say, well, let's just start with this one. It could be nitrogen with a -3. I could say oxygen with a -2. I could say iodine with a -1. You could say any of these, okay? They all form just one anion. Now the next one down, it says identify 3 elements that form more than one cation. So let's do that one in red, right? Well, if they form more than one cation, now we're talking about these guys right here, okay? Any of those, except for zinc, of course. Zinc only forms one anion, and so does silver. So in this case, I could say Fe, it forms a +2, and Fe with a +3. It does both of those. Okay, there's nickel. Nickel can form a +2, or it can form a nickel +3. And then a third one, let's do copper. Copper can form a +1, or copper can form a +2. So, there's just some examples of 3 elements that form more than one cation. Okay, so now let's kind of drag this up and do that. In what region of the periodic table are these multiple ions usually located? Well, you probably figured that out really fast. Where are they? The ones that are multiple ions in general, and I'll have to say usually, because look, here's one that's actually in the P block, right? But in general, these are in the D block. And we've talked about the D blocks and the S block and the P block, right? And the F block. So most of these are in the D block. But I can say, but some are at the bottom of P block. And you can see that right there, right? We do have some that are at the bottom of the P block that do the same thing. So number 2, it says consider the ions of potassium, K, and sulfur, S. Write the chemical formulas for all possible ionic compounds involving these ions using the simplest ratio. Well, let's see. Potassium is here and sulfur is here. So what is that going to look like? Well, that's going to be K with a +1 charge and sulfur with a -2 charge. We're going to crisscross applesauce, right? So this guy is going to come down here, and this guy comes over here. It looks pretty messy right now, right? And it's going to be K2S, and that's going to be the answer to that one. That's the only compound combination that we can do there. It's going to be K2S because we crisscrossed applesauce, right? And then let's look at number 3. Consider the ions of iron and sulfur. Oh, well, if we do iron and sulfur, now it's going to get different because we could do an Fe with a +2 plus sulfur with a -2, or we could do Fe +3 plus the sulfur with the -2, okay? So in this situation, the first one is going to equal FeS. Why? Because this is going to be Fe2S2, and remember we reduced it down to the smallest form. So that's going to be FeS. And then we also have this other one over here. This is going to be Fe, we put the 3 there, we put the 2 there. So that's going to end up with Fe2S3. Okay, so we've got that one as well. So there's our 2 possible combinations for number 3. All right, let me see if I can move on here and kind of boogie through a few more of these. So number 4, it says circle the symbol for the metal in each of the compounds in Model 2. So the symbol for the metal in each of the compounds. Well, let's see. I want to circle them. So this is a metal, 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 this is a metal. Do you notice any kind of pattern here? Where is the metal at? It always goes metal first. See that? And then non-metal second. So there's something you need to know. The metal is always written first in a compound. So which element comes first in the compound? The metal. Okay, so that's going to be the metal. Number 6, use the table of ions in Model 1 to answer the following questions. So we're going to have to toggle back to page 1 to do this. In the compound zinc phosphide, what is the charge of the zinc ion? Well, if I go back to the first page, what is going to be the charge of the zinc every time? And let me, by the way, I'm going to erase some of this so that we can kind of see these charges again. I hope that's okay with you. It was getting a little messy there. I do a lot of doodling when I'm learning. I don't know if you guys do that or not. I love to just mark up everything when I'm learning stuff. It's just how I learn. And it's okay to do that. So let's go back. What is the charge on the zinc? Well, every time it's going to be a +2, right? So let's go back to the other page. And it says in the compound zinc phosphide, what is the charge on the zinc? Well, we know it's going to be zinc with a +2 charge every time. And let's go to letter B. Right here it says in the compound zinc phosphide, what is the charge on the phosphide ion? Well, again, let's go back to the chart on the other page. And phosphide is right here, okay? And the charge on it is going to be a -3. So let's come back over here and let's put that in. It's going to be phosphorus with a -3 charge. So what would we say the actual formula is? Well, that's going to be zinc with a +2, phosphorus with a -3, crisscross applesauce, 3 and 2. That's going to end up being what? Zinc 3, phosphide 2. Oh, there's my alarm going off. So this would be the actual formula for zinc phosphide, just in case you might want to know that. So explain why a ratio of 3 to 2, or why a 3 to 2 ratio of ions is necessary. Well, we learned that the zinc is a +2 charge, so +2 plus -3 has to equal 0. Well, clearly that's not happening right now, is it? Well, we need to make it happen. And in order to do that, we're going to have to use the least common denominator. Well, what's the least common denominator between 2 and 3? Well, that's going to be 6. That means I have to change this to a +6. Well, to do that, I'm going to have to multiply this bad boy by 3. And this is going to have to be a -6. So I'm going to have to multiply that guy by a 2. And that's going to give me 3 times a +2 gives me a +6. And then we have 2 times a -3, it gives me a -6. And that, of course, really does equal 0, okay? And so that's where we get that. All right, number 8, the compound carbon dioxide has a name that gives you a hint as to how many oxygen atoms are in the compound. Okay, is there anything in the name zinc phosphide that indicates that there are 3 zinc and 2 phosphorus? The answer is no, there's not. Okay, if it's dioxide, we know di means 2. But for zinc phosphide, it doesn't tell us that, does it? We just have to know what their charges are so that we know what the ratio is going to be up here at the top. Okay, kind of strange. Is there any other ratio of zinc and phosphorus ions that could exist? For instance, could you have a ZN2P or a ZNP2? And the answer is no, we cannot. And the reason why is because all charges must add up to 0. Every time. They always have to add up to 0. And because they do, there's no way that we can have anything else but the ratio that we have. Okay, I'm going to stop here because I'm going to have a Google Meet. But we will continue this with a part 2 video after I have my Google Meet. Okay, see you in a little bit.